So, Heart Week this week, and just kind of a quick review of law of signs, and then we get into this thing called the ambiguous case. Ambiguous means that you can't tell. I'll give you an example. If I said that on Monday we did this, you can't really tell if I mean on Monday, most recent Monday, which would probably be logical. Okay, or it could have been a different Monday. That was ambiguous. It wasn't totally clear. Okay, if I said, my friend told me that, was it clear which friend I was talking about? No, that was ambiguous. All right, so if you can't quite tell, that's what ambiguous means. So this triangle situation is not ambiguous. I'm going to make you a nice clean one that's easy to understand. If that's 3 and that's 4, then clearly that's 5. You know why? In a right triangle, a squared plus b squared equals c squared. That's not ambiguous. That's gotta be a 5 there at the end. All right. This is something that's not ambiguous either. It's gotta be a certain angle. Would you take a moment and use trig to figure out what angle that has to be? Pause for a second while you're figuring that out. By the way, do you have to use sine? No. Could you use cosine in this case? Sure. Could you use tangent even? Sure. Any of those work. I will tell you that as we move into as we move into the trig part of pre-calc, that a lot of times we use inverse tangent. Okay, that's going to kind of be the standard. I'm not saying always, but any of those would give you the same answer, but it's just one of those things to kind of get used to. Is a lot of times if we have a choice, we'll choose the tangent option. Inverse tan of 4/3, and dice of destiny. Did random person get row 1, person 2? That would be you. Looks like you haven't got your calculator out yet. I'll give you a break. That person's partner. What'd you get? 53. Raise your hand if you had 53.1-ish. Okay, good. Then that is an example of just using trig. Is that an example of using the law of signs? No. No. Okay. What if I gave you another triangle? This one, I bet you some of you are going to know. This is 5, and this is 13, and this is theta. Okay. Except this one, if it was a right triangle, does anybody remember what this side here would have to be? 12. 12, very good. 5, 12, 13 is a classic triangle. All right, but what if I said, actually, I can tell you it's not a right angle? Well, if it's not a right angle, then it can't be 12. See what I mean? Now, I made this angle kind of ambiguous. You might be able to look at it and say, oh yeah, that's definitely less than 90. But if I didn't tell you for sure what that angle was, it wouldn't be clear if the side was bigger than 12 or less than 12. Okay, that's kind of an example of being ambiguous. All right, but now, if I tell you that this angle over here, let's say I tell you this angle right here is, I'm going to make it 21 degrees. It is possible that, remember, this is not a right triangle. It is possible that I just made an impossible triangle. Do you remember from yesterday that there are situations where, nope, you can't make a triangle like that. It won't work. All right. So go ahead and figure out did I make an impossible triangle, or use the law of signs and figure out what this angle must be. I'm going to call it theta for our unknown angle. Just having you practice using the law of signs. If you have an angle and the side across from it, it's all set up for law of signs. Pausing for a second. See what you think that comes out to be. All right, here's the setup for law of signs. Sine of, well, again, this is A over A or B over B or C over C, and it doesn't matter. I did give you the tip that the important angle, there's only one angle here. Do you remember which letter that's supposed to be? C. Does it have to be? Well, actually, it's kind of ambiguous because it doesn't really have to be C, but it works best if it's C, and that'll especially be true with the law of cosines. But I'm just trying to remind you that I'm going to choose to make the important angle be at C. All right. You might think, oh, it's got to be the hypotenuse. Nope. That's when we're right triangles. Okay, so I'm going to say sine of 21 over 5 is equal to, well, this angle I don't know. I'm going to call theta. Sine of theta over 13. Now, how could there ever be an impossible question? If you're asking for an angle that's not possible, it'll just fail. It'll say you can't do that. All right, what did you get, Miss S?
68.7.
Anybody verify 68.7? Okay, a lot of people are agreeing. And does that seem possible? I'm not saying does my drawing look right. Just saying they didn't give me some angle that's impossible, did they? All right. So if we add up these two, that's almost 90, which would mean this almost was a right triangle, except that was almost a right angle. Okay. All right, so that was just an example of a law of sines question. Let's just do one more law of sines question. We're going to keep a nice, normal, this is going to be a 100-degree angle, and this side is going to be 10. And this side over here I'm going to say 14. So now you can figure out anything, any of the angles, any of the sides, whatever you think would be the better thing to figure out. So I'm going to choose for you this time. I'd like you to figure out for me what this angle right here is. And if it doesn't work, as long as you're confident you set it up right, if it doesn't work, that means I just drew an impossible triangle. That happens from time to time.
Is that 140?
That's 140. Oh, wait a minute, I shouldn't. No, I'm sorry. That's impossible. I should have just erase that. Sorry about that. Get rid of that. I was thinking first degrees, and then it's not degrees. It's a side, and then I thought it was a 0. So, yeah, kind of a train wreck there. 100, 14, 10. Did I make an impossible triangle? Sine of 100 over 14. That's how you'd start, right? Can you finish it for me?
No.
Sine of, come on, you do this. It's not that bad.
Theta.
Sine of theta over, don't know, do you?
Yeah, that's why I'm confused.
So I could call it x. Can you solve an equation that has two variables in it? No, not unless you can find another equation like it. Well, we actually could find another equation like it, but maybe to get this angle, we're going to have to start by figuring out something else. Know what I mean? What would be a smarter thing to start with and then would almost instantly get us that answer? Yes?
Find the other angle.
Find the other angle. Okay, I'm going to call this B for beta. You could call it anything. I'm just kind of choosing B. Everybody solve for B, because that one you can do, because then we won't have two variables. We'll only have one variable. After you get an answer, check with your partner, see if they got the same thing. Pause for a second while you try that. So I hope you set it up with sine of beta over 10. Then I'm just going to multiply both sides by 10 preemptively, because I want to clear that out, times 10. And then it's 10 times sine of 100 all over 14. That's a nice exact answer. But, Alex, can you tell me what you got for your decimal answer for that? Not the final answer, just this decimal here.
Oh, 0.703.
703, okay, thank you. Equals sine beta. And then how do you finish?
Inverse sine of
Inverse sine, excellent. What'd you get?
44.703.
44.7 degrees. Raise your hand if yours would have rounded to 44.7. Okay, awesome. Then, did I get my answer directly? No, but I've got it indirectly then. Because if this was 100 and this one's 47 or 44.7, then I can figure out the last one. All right, so sometimes you don't get your answer just instantly. You gotta like get it indirectly. All right, so that's enough of our law of sines examples. I want to go now to this triangle. Everybody try getting the answer for these angles right here. Either one of them. And obviously it says, what's wrong with me? There's something wrong. I want you to try to figure out what's wrong. What's wrong with this triangle? Yes, it's an impossible triangle, but what's wrong with it? Hint, it's not 8. I mean, it says it's 8, but it can't be 8. Why can't it be 8? All right, I'm going to pause for a second. We'll give that one a try. Why can't that be 8? Okay, so I was talking with one of the kids about this, and he said, well, 8's the shortest side, right? And he said something about how, I'm going to call this side x. He said 8 and x together have to be more than 12. You get how that works? 8 and x have to be more than 12. Okay, so bottom line, it can't be 8 because 8 being the smallest side, if I even just doubled it, I'd have like 16. All right, I'm not explaining the argument well, but it was a pretty good argument. All right, I'm going to go back to, I like also this argument that I've heard from other people, that if you put this in, that's going to make a right triangle, right? Would everybody please figure out, if this was a right triangle, there is some number where it would be a right triangle, right? And it wouldn't be 8. Figure out what that number would be. Everybody figure out what that side would be if it made a right triangle. Compare with your partner on what you think that length would be if it was going to be a right triangle. Remember, if it's a right triangle, a lot of easy things work, like sine, cosine, tangent of 60. Okay, I'm going to pause again. Okay, so a student said we should take this and then multiply both sides by 12, so we'd have h alone. It's true. 12 sine 60. If you haven't already typed that in, type in 12 sine of 60. What'd you get? Front row kid?
Me?
I'm not naming on the video.
10.4.
All right. If this side is actually 10.4, why wouldn't 8 have worked? If I'm gonna set it up again. Let's say it was like this, and this is 60. If we know that the hypotenuse side would make it 10.4, then isn't that the shortest that side could be? If you make it any smaller than 10.4, it would just like dangle there. See what I'm saying? So a side of 8 would be like that. It wouldn't even touch. Does that make sense to you? If this is 60 and this is 12, then the 8 cannot connect those sides. Yes?
So, like going back to the triangle that like we originally
This one?
looked at.
Yep.
So if you put that line in, wouldn't that be a 30, 60, 90? And therefore h would be 6?
But it's labeled right now. It's kind of gross. That's 60.
Yeah.
It looks like it looks like it's supposed to be the 30 in the triangle. So don't trust your eyes. You got to trust the
I see.
angle. I know this looks like a 30-degree angle, but it's actually 60, and so you got your side ratios off. All right, so back to this. All right, so I like to draw my triangles a little more ambiguous, which means you can't really tell if this is a 30, a 60, or a 45. So anyway, I can label it 60 and then it just is. All right, so I'm trying to get across a point here that when you get this last side of the triangle, we're usually going to call it A, the A side, and that means this is the A angle. And remember, the book likes to use alpha, so they're also going to use alpha for that angle. This little A side, if it's not big enough, then it won't even connect and you won't have a triangle. Does that make sense to you? All right. If I make it extreme, sometimes that helps people. If I make this only 1 inch versus the other one being 12 inches, do you get that there's no way that it could connect if it was only 1 inch long? Right? Okay, what is the first length where it would finally be long enough to touch? We just figured that out a second ago. 10.4. What happens if it's 10.4? You get a right triangle. What happens if it's 12? Wait a minute, 12? If it's 12 long, you'd have to have it go this way to be 12 inches long so that it could be the same as this side. Do you get it couldn't swing to the left if it was 12? Like you couldn't go in here? Because the other one's 12. It couldn't also be 12 and still make a triangle with a 60-degree angle in there. All right, so here's the numbers that it's all about. This A side right here, this A side, you figure out what's the shortest it could be by making a right triangle. You know that the longest it can be where it could swing in both directions would be that it could be between 10.4 and 12. But as soon as A gets to be 12 inches long, then it can't go and swing on the inside here. It can't be 12 inches long in there, so it has to go 12 inches long this way. And then it's not ambiguous anymore. So what's the ambiguous case? The ambiguous case is that length of that side is longer than 10.4, but less than 12. So let's give an example. Let's say I said it was 11 inches long. Do you get 11 inches long? You could not make it go straight like this because that distance was only 10.4. So it's a little too long for that. Can't look like that. But could it look, if it was 11 inches long, could it look like that and be 11 inches long? Yes. Could it also look like this and be 11 inches long? And then this is the critical part right here. What do you know about these two angles? They're the same, because angles across from sides that are equal will be the same. So now, if I told you this angle right here was actually 60 degrees, and you'd be like, that triangle doesn't look right, Mr. Server. You're right, but we can trust these sides. Maybe I'll make it 70 just for the fun of it. I'll make it 70. If that's 70 degrees, then instantly that's 70 degrees, and then instantly what's this? 110, because they have to add up to total of 180, these two, right? Okay. So this setup right here, everybody draw it if you haven't already, is called the ambiguous case triangle. Because you can't tell if the 11-inch side is swinging left or if it's swinging to the right. And so you can't tell if your final answer triangle is this red one, which I'll make the smaller triangle. And you can't tell if it's instead this blue triangle. Do you see, if I told you that this is 60, this is 12, and this is 11, you can't tell whether to have it swing to the left or swing to the right. You know it can't be straight up and down because we already figured that out. What was straight up and down height? Ooh, so you also know that if you want it. But we didn't really need it. Okay, now here's the part that'll really bother some of you. I'm going to ask you to use the law of sines to figure out this angle. Just a second here. To figure out this, I'm going to make it bright yellow. This yellow angle right there. You might think it's 110 because I said this was 70 and 70, but remember I just made that up. This isn't really 70, that's not really 70. So how are you going to find those law of sines? Do you have 3 pieces of info? Isn't that enough to use the law of sines? Sure it is. So here's the law of sines in case you forgot it already. Sine big A over little a. Sine big B over little b. And sine big C over little c. And I'm asking you to find this side, or this angle right here, and be prepared that it's not necessarily going to come out how you think it's going to come out. Because that's why we have to spend so much time on this problem, because it's complicated. So set up your law of sines, compare with your partner, and try to figure out what is going on. In the end, I'm going to call it theta. I want that angle right there. We don't know that those two were 70. That's why I crossed them off. We know 60, we know 12, and we know 11. Pause for a second. Figure that one out. Okay, let's see what you put in. Would you agree that the 60 degrees was the key angle? I'm going to put it under C. Does it really matter for this kind of question? It actually doesn't, but I'm going to put my 60 here. You could have put it under the A or the B. It doesn't matter. I know it's got a label of A here. I get that. Like I said, it doesn't matter. I'm warning you because in the law of cosines questions, the key angle is supposed to be C. So I did it that way. And then this is an 11. And then this mystery angle theta, I can call it A or B. I don't care. I'm going to call it B. And I'm going to say that this is theta. And then little b is 12. The problem is when you solve that, crazy things happen. Well, what'd you get? Did you use inverse sine at the end? Okay. Let's just finish it off and see what you get. I'm going to pause for a second while you crunch out the numbers. Okay, so after doing inverse sine of theta, I got 70.9 degrees, 70.9. Now the thing that should bother you, and I could tell it didn't bother a lot of you, you're like, well, yeah, it's 70. It can't be 70. It's bigger than 90. That can't be 70. All right. So think about it. Look at it. It had to have swung to the left of straight up and down. If it had been straight up and down, we already know that would have been a 90-degree angle. That has to be less than 90. So how, I mean, I got a 70? What you got was this was 70. When you got that 70.9, you actually got this answer was 70.9 degrees. And so this is also 70.9 degrees. And so this wasn't actually 70. It was actually, I'm going to do my math here on my calculator, 180 minus 70.9. And the answer was actually 109. And I know a lot of you were like, well, I just thought the answer was what it said. It can't be. All right. Let's do another one like this so you can see how these ambiguous case questions work. Everybody look at the gray slide. I'm going to tell you, I'm going to save you some time. A length of 12 right here can't work. I want you to take a guess why a length of 12 right here can't work. It's too small. Everybody figure out for a second what this length would be if it was a right triangle. Call it H, and it won't be 12. Pause for a second while you figure out if H was a right triangle. You don't have to use the law of sines then. You can just use much simpler trig on right triangles. Pausing. So did you guys get that it would have to be 14.6 inches long right there? Do you get 12 couldn't make that gap? It's not big enough. It can't be straight up and down there. So 12, no solution if this is actually 12. Remember the very first answer of yesterday's homework was no solution. You can't make that triangle. Won't work. What if it's 21? Think about it. Could it even be in here if it was 21 long? No. What the longest it could be is, and in fact, it couldn't even be 20. Do you get how it'd have to be less than 20 if you were going to like snug it right up against the other 20 there? It would have to be less than 20, so 21 can't be on the inside, but could you make it 21 if you go this way? Sure, you could be any length if you go that way. So it could be 21 if it went that direction. Then it's not ambiguous. It has to go that direction. But 15 is the ambiguous case. Why? Because it's long enough that it's not straight up and down. Because do you get, this was 14.6. It's not 15. If 15 would go a little too far. See, like 15 would go through that line. They can't do that. So, instead, this forms the ambiguous case, which I think you should go like this. Call that 15. And then go the other way. Call that 15. And then didn't you just make an isosceles where these two have to be equal to each other? Yes, you did. And now when you do law of sines, you'll get an angle. If it says that this angle right here is like 30 degrees, are you going to just agree and go, oh, I guess it's 30? It's got to be bigger than 90. So if you get an answer like 30, what you're really getting is this angle. All right, work with your partner to figure out what, in the end, I want to know how big this angle is, but this green one right here, oh, like green's terrible, can't read. Say this black angle right there, that angle, that one, I'm going to call it theta. Figure out that angle for me, but don't just automatically blindly trust your calculator after you set up the law of sines. Yes?
How did you know that 15 would be too long to get a height?
Because we figured out the height back here, and it was 14.6. This one is 14.6. We did that together. We used law of, or actually just used sine of 47 was equal to h over 20. And we times by 20 on both sides. And bottom line, the height is 14.6. This is 14.6. So it can't be 15. So if you have a side that's 15, it has to swing like this, in either to the left or to the right. And it makes this kind of like a triangle inside of a triangle. All right, I'm going to pause for a second while you guys try to figure out. Well, in the end, you probably figure out all three of these angles. This one, and this one. But I want to know the one that's right here. Pausing. Okay, so I had a student set this up for me. Sine 47 over 15, because this goes with this, equals sine of theta over 20. Because this theta, but really the kind of the ambiguous thing is, are you figuring out this one or this one? And again, in the end, I want to know this inside one, but one thing at a time. I solve this and I get an answer, and if my answer is less than 90, I go, maybe I didn't find that one. Maybe I found that one. All right. So now let's do a little bit of math. We're going to multiply both sides by 20, and I'll save a bunch of time. Inverse sine of all that. What was that angle that you got? I'm going to call on, let's see, in the back, Miss F in your group. What did you guys get for your angle? The smaller one, the one you got at first. Anybody verify 77.2 degrees? Now, do you look at this triangle and go, wait a minute, that can't be 77 because it's bigger than 90. So you can't tell which way this triangle was drawn. All you knew was this was 20 and this was 47 and the third side was 15, and you couldn't tell which way it went. So apparently it actually went this way. And so we found that angle first, and it was 77 point what? Thank you. And then therefore, if I take 180 minus that, can you help me with that one? So it turns out this angle I really wanted right here was 102 point, did you say 8? Thank you. Can anybody verify 102.8 was what you got also? Okay. So if I say this side, 7. This side, 6. This last side is here, but I'm not going to say exactly which way it swings. Would you agree that if this last side here was actually like 6, there'd only be one way you could go? You know, of this way or this way? If this last side was 6, do you see that it can only go one of those two directions? If this last side was 1, do you get that it couldn't even connect? It wouldn't even make a triangle. I should probably tell you what angle this is. I'm going to go with a 30-degree angle this time. All right, so a side of 1 would just be too short. A side of 6 would be so long that it'd have to go this way. What would be something that's ambiguous? That length of that side would be like what? Somebody want to give me a number?
12.
Now, if it was 12, I'd know it'd have to be this way, because I couldn't go inside if it was 12.
4.
No, it couldn't be 12. Okay, could it be 4? The only thing I'm worried about on 4 is, do you get it that 4 might not be long enough to connect these two sides? We could figure out how long that side would be pretty easily with trig, but I think it'd be safer to go with something like 5. You know, your 4 might have worked, but I just don't know for sure. But I will guarantee you that 5, 12-minute warning, that 5 would give you the ambiguous case. I've drawn it straight up and down, but it can't be. 5 is going to go like this. It's not going to go straight up and down. And it would go like this. This is your last ambiguous case question. And this time, I want to know, that's 5 and that's 5. This one was 30 degrees. First of all, did I give you enough information? Yeah, all you got to ask yourself is, did I get 3 pieces of info? And you did. One side, 7. This side was 7. In fact, I gave you too much info. I'm going to erase the 7 side. Sorry. That would make it obvious. Maybe not obvious. It would give you too much info. All right, so we're going to go with this side 6. This side's 5, but I don't know if it's here or here. And this angle's 30. Would you please figure out how long this little short side is? I'm going to call it Q. I'm going to pause for a second. I'll use law of sines in the ambiguous case. Okay, so I hope you set up sine of 30 over 5 and sine of theta, the unknown angle, which is either this one or this one, which are the same, or it's this one, but it's hint, always going to end up being less than 90, so it's pretty much always going to be that one. And when I did it, I got 36.9. Raise your hand if you got 36.9. Awesome. Do you get, I can tell right away that that's not a really big angle bigger than 90? So it must be these two. When I say two, it's because they have to be equal. So if this is 36.9 degrees, then this one must be 36.9 degrees, which means the remaining one on the inside here where I drew the angle, or the little arrow, must be 180 minus 36.9. So then this angle is 143.1. Now, a tip for you. These get so intense, if I were you, I would redraw the triangle, make it cleaner. 143.1. 30 degrees. This side is 6. This side is 5. And the only thing I didn't know was that side. Does that make sense to you so far? All I did is redraw this blue triangle right here, and I pulled it out and I put it down here. With this side is 6, this side's 5. This angle's 30, this angle's 143.1. Okay. Now that I know these two angles, I know the third angle. If I were you, I'd always figure that out. I'm going to put 180 minus 30 minus 143.1. And I got 6.9 degrees up here. Final answer, sine of 30 over 5 is equal to sine of 6.9 over the one side I don't know right there. What am I going to call that? I'm going to call it Q, X, M, whatever. And what did you get for that final side? Anybody verify 1.2? A lot of people are saying yes. Awesome. Okay, those are one of the hardest things. It seems like you've made it through. Can I summarize for you what you're supposed to have gotten out of this? There are scenarios where you're given this side, this angle, and you have a third side, but you can't tell if it should go this way or this way. And when that happens, if that third side was, let's say, 7, it could either go this way or this way. And so you draw this little scenario and set it up, and you get all the possible answers. And then you'll be able to see whether the triangle was actually this little red one, or whether the triangle was actually this big green one. Because it's ambiguous, it could be drawn either way. You can't tell. There's not like a right answer. Oh, it's for sure this way. No, the triangle could either be the red one or the green one. And then they're going to ask you, so then your answer could either be like, how long is this side here? Or the question could be like, what's this angle? And those angles are always equal. That's one of the other keys to this whole thing. And you always use the law of sines on these problems. And that would start with sine 43, goes with the 7 side. And then the other angle, we don't know what this angle is. I'm going to call it theta. So sine of theta over the other side, which was 8. You'll get an angle. That angle is sometimes confusing because you're thinking you're getting this angle, but it ends up being like a 50-degree angle, and you're like, that's impossible, but it's actually this angle you're finding. All right, so there's a summary, and then what I want you to do for your homework for tonight, would you do a few of these things? You stay caught up. This class isn't that bad, but you don't want to fall behind. Going to do problem 13 and 14, and this is that one letter I was trying to describe yesterday, and I couldn't remember what it looked like. That is like a capital C in the Greek alphabet. So if you just want to put a big C there, capital C, it obviously goes with lowercase c. I don't know who on earth would know that, but the book likes to use alpha, beta, and whatever C is called in Greek. But that's the Greek letter C. Okay, so we should do this one. And if you're like, gee, I don't know how to draw the triangle, that's the point. It's ambiguous. You know it's a 6-degree angle. So here, I'll help you set up the first one. You know it's a 6-degree angle. Everybody start to keep your life simple and always make this one horizontal, like the horizon, right? And then make your angle. I'm making it even bigger than 6 probably because I just want to be able to have it be open enough to like work with. And then if this is a Greek A, I'm going to make it a capital A. Then the side across from that is this little side here, which I don't know which way to draw it. It could be here, it could be here, it could be there. That's the point. It's ambiguous. You can't tell. But that side's 57. So if I were you, I'd always draw all 3 options, maybe not even the middle one, but this option, this could be 57, this could be 57. And you don't know this one, but you could use math and figure out the height because that's a right triangle. But you don't really, honestly, you don't really need that one, but it's neato that you could find it. So there, I've set it up. Where's that B though? You have to know this side is 100. I'll put the 100 in. Do I have 3 pieces of info? Yep. So now I can use the law of sines. Don't forget, like when they give you this C, then that's obviously the angle across from this side C. All right. Now, one more. You can do 15, skip 16. And I'm sorry, I lied a little bit. And then there's one more. Why do I keep giving you these bearing problems? Because we're going to have another bearing problem in the next test. So make sure that you practice bearing. You can't afford to just be bad at that. That was last chapter. It comes back. So keep practicing these. There's good examples and the keys there. So there's 4 questions for tonight. And it's a little on the heavy side, but you know Friday you're going to have a super easy day, right? So the week gets better. Okay, it's all I got for you for today.